Okay, Bernard, I'm not really sure where to start, so I'm just going to take the side off of this engine by hiding it, and then zoom in and show you the details. Oh, you can see the steam pistons right there. They just disappeared. They were behind this. That's where the steam pistons operate. That's what gives the extra mileage, because you can use the waste heat to get power. I'm just going to select something out of the way that you can't see. Exhaust plate. Okay, right here. Oh, there we go. You can see all the internal bits and pieces. There's the piston here, steam piston. Whoop, that's an exhaust. There's the steam piston. Okay, it's a double-acting steam pistons. These two chambers here alternately fill with fresh steam produced by the power piston up here, the gasoline engine. And when they exhaust, oh, excuse me, I misspoke. It's both sides of this piston. And when they exhaust to both sides of these two pistons, so it's double acting. And then this piston over here is inside a separate cylinder, and it's got ammonia, and it's a refrigerator for condensing the steam back, and it runs, let's see, up through there, back into the engine. It comes through these two ports into here, and then down the sides of the cylinder. And let's see, yeah, there's the outer part of the cylinder. Let's see if I grab the piston in there. Well, I grabbed the exhaust and intake ports. Hold on. There we go. No, that's not it. That's the outside. But anyway, this water comes down between here, another wall, and then the piston is inside that. So there's a space in there for creating steam. And it comes down through these edges here, right here, here, and here, to keep this area hot. It goes to the core of the engine, and once it gets there, it comes back through a system of valving. Let me show you. Okay, like right here, these stripes here, connected with these ports, create the valving. As the engine rotates, they open and close to provide the steam to alternate ports here, and then to transfer it to these two. And then when it condenses, it comes back through here up and completes the cycle. And these are radiators out here. Let me get a couple. There we go. Let me zoom in on that a little bit. These are the radiators out in front. There are two of them because this piston is double acting. When it moves inward, this piston here, when it moves inward, it compresses gas in one of these. And then when it comes back, it compresses it in the other one, liberating the heat. And to minimize moving parts, the fan supports the coils, and the coils support the fan, and they rotate together. I have an engine cover on here. This would be a filter. But as you can see, it's got these fans. Okay, now, let's go to another one. Let's go to my Fire Dragon. Here we go. Now this is the Stirling cycle. This is the one that cools the engine I just showed you. It runs off the waste heat. Let me pull in a little bit. Hold on. Computer's a little slow. Whoops. Let me pull out a little bit. My computer's having a little trouble. Anyway, these are transfer ports. They're showing right now. They'll disappear behind the clutter in a second. Here's the piston chamber. Oh, there we go. And this is the hot side over here. This blue side is the cold side. Let me make it transparent so you can see some workings. Okay. This is the same as the other one. The only parts that move are the engine blocks and the pistons. Nothing else moves. No levers, no cams, no gears. This section right here. Whoops. Yeah, this one. Thank you. I got a cameraman in the background. Help me, because I'm holding the camera. Okay, this section here rotates with the pistons. The whole engine rotates this way. But as it does, because this is on an angle with the main engine block, which rotates square to the main axis, this is on a 15-degree angle. So these dip in on one half the rotation, and they're pulled out on the other half, as you can see over here. And it's a double-walled construction in the pistons. Let's see if we can, well, There's one piston there. There's one internal to that. Oh, we can't get hold of it. But the air flows outward to the chamber where it's heated. Let me pull back here a little bit. Show you where it's heated. Right about. There we go. Okay, let's make it so you can see it. Shaded. Okay, pull the plug. This shape I'm pulling out now would hold the ends of the exhaust tubes from the gasoline engine, or it would hold propane or butane or natural gas jets for heating, because there's no starter motor in my car. You fire this engine up and it produces the electricity to start your car. It's a dynamo, not an alternator. Anyway, right in here, as you can see, the pistons are out of alignment. That's an artifact of their construction. But over here, we have some actual videos of it moving. And this is our baby right here. It's going to start her up. That's a gimbals, because like I said, we use it for keeping the car on the road, whether it's snow or ice or whatever. But as you can see, the pistons move very smoothly. And their total motion along on their axis this way is only 15 degrees in each direction. They move 15 degrees, come to zero, move 15 degrees, come to zero. But it's the smoothest action I could come up with. There's no moving parts other than the pistons and the engine block. And all the valving's done internally, like I was going to show you over here. And over here, I think I can show it to you. I'm going to do some views here, back it up. Yes. Okay, let me grab these. Whoop, zoom in. Okay, duck out them. Let me take out those pistons. And then close it again. Okay. Now as you can see, this valving here, there's airflow across here. And then there's airflow coming back, but instead of going straight across, it goes into the transfer tubes. It goes across. And as it comes across from another wheel, whoop, let's see, let me redo that. Okay, the hot and cold comes straight across here. But, hold on. Oh yeah, the cold comes this way, so the hot's coming this way. Yeah. So the exhaust of the hot air comes over here. And then the air returns this way, goes through this transfer port, and it would be coming back like that. Through a valve like that, and across this way. And then it would come up through, right over here, right here. And then it comes back into this piston and be reheated. And it's a complete cycle. This is actually two engines on top of each other. Each of them is 4-cylinder. But the way the valving worked out, I could put them on top of each other. Oh, and now here's a video of the one for, this isn't actually the one for breaking the sound barrier. It's the same geometry, but it only has 6 power pistons right here. So this one would be for making 125 miles to the gallon, because we could turn off most of the pistons, just run on 2 at a time, because there's so much power per pound. And over here, let me show you that one again. I think that one. Oh no, here it is. It's in here. Oh yeah, this is the one for breaking the sound barrier. The one I just showed you has 6 cylinders, and there's this one right here. But this one has an extra cylinder here, an extra cylinder here, in each wedge. And there are wedges with no cylinders at all. No power cylinders. There's still, or no steam cylinder, excuse me. There's still a power cylinder, but it's used for compressing air, because this engine is a hybrid. And it stores its energy in combination with air, electricity, and momentum of the engine block itself, which acts as a distributor, and the timing and everything. So all this stuff is all tied together basically to break the sound barrier, or some get 120 miles per gallon. Can you bring up those other 2 engines, showing how they hook to this one? Because we're coming on 9 minutes and a half now. Okay, there's one of the Stern cycles. It would be fed from exhaust tubes coming across here. And then over here, it'd have the same thing. And they're on gimbals. And they're on gimbals for keeping everything stationary. Well, anyway, I thought you might be interested in this stuff, so thanks for listening, and hope to hear from you real soon. Thank you.